Okay, right now we keep talking about convergent and divergent. Okay. Now let me see this question. Let's determine when sequence convergent divergent. Okay. Give you example. Here's give you 3 questions. Oh, this. Now ink. Okay. Use this pen. First one. 3n 2n plus 1. Okay. Second. Yes, 2n over n squared. Third. 2n over 1 plus 2n. This is a sequence. Now, which one is a convergent, divergent? Okay, here's a sequence. Okay. Before doing that, we have to understand what's the difference. Okay, there's a sequence between sequence and series. How to determine sequence convergence? Right? Question is, which of those above are which those sequence are convergent? Or convergent or divergent? The sequence that in Chinese translated Chinese as a 数列, right? How to determine the 数列是收敛和放散. Okay. The principle is the rule is determine sequence A1, A2, A3, something like this, right? This one, AN. Determine the sequence convergent divergent. Actually, just need to find the limit. If this limit is exist, right? If it exists, right? C or L something, any number. So we say there's sequence convergent. Right? Now we use this the difference from the series. Series are sum of this, right? If this exists, summation, we say the sequence convergent, right? This series convergent. Sequence convergent, we just take out as nth term, right? That's nth term. Finally, the number. What's the final number? If it exists, that's means sequence convergent. If a summation of this make limited exist, we say the sequence convergent. Okay. Now, based on this principle, let me see first one. Okay. Find this limit. Let's approach infinity. 3n over 2n plus 1. Right. Very simple. Right. The limited is 3 over 2 seconds. So there's a convergent. Right. It's convergent. Now next, As n approach infinity, as n approach infinity, look at this. Now this is limited. This increase, numeric increase, is speed much faster than this one. Denominator n squared, right? That's infinity. So the limit did not exist, right? So this not convergent, actually divergent, right? Third, right? Here we know divide both the numerator and the denominator by 2 to nth power. Right? So we got so what's the limit? Is 1. As the limit exists, so that's a convergent. This question. It's how to determine a sequence convergent. Now, next question. Let me show you how to determine sequence convergent. The question is same. One is summation sine n or n squared. Okay, absolute. Start from 1 to infinity. Second, and start 1 to infinity. E to nth power. Third, n plus 2 n to q third power. This sequence. Okay. The sequence convergence, the rule is if the sum first term, second term, third term, and until last term added together, if this exists, as constant exists, right? So this sequence convergence. Now, let me see sum of this. Is it this or not? First term, second term, and 5 term, nth term, and the last term, put it together. Right? Put it together, add it together. If we get one constant, we say the sequence convergent. So let's miss first one. No, by the rule, we use by rule to do that. Okay, we can use the comparison. Right. We know this one less or equal to 1 over n squared. Right. The big one, if convergent, then this convergent. So right now we know because n squared 1 over is very famous. This convergent, right? So the big one, small one, has convergent. So this convergent. Right. Next question. Here, let me see this. Actually, this one, we look at what it is. N is 1 just means N is -1, right? Plus N is -2, plus N is -3, right? N -4. Now, it's actually 1 over E, 1 over E squared, 1 over E3, E4. It's very easy, right? We can find it. This series is geometry sequence, right? This common ratio, right? Common ratio is 1 minus by the formula 1Q first term. Common ratio is 1 over E. First term is this. Right. The Q. And next term divided by, okay, second term divided by first term, third term divided by the second term. Previous term, next term divided by previous term. The ratio is 1 over E. The Q is 1 over E. First term is 1 over E. Now we calculate this. Does it exist? Right? Right? It exists. Right? So this constant. So this convergent. Oh. Third. We can also apply for comparison rule to determine this convergent or divergent. So we compare this one to N squared, right? With if not familiar with this one, we can simplify this first. Right? Here we divide by what is actually we just compare those one. This one must be less than big one. Less than this. Now, what is convergent? This one must be less than N cubed plus we can plus this when N plus bigger than 2. So what it is? 1 over N squared. Okay, this one we know. We usually take this one to compare some series that determine this the sequence of convergent or divergent. Right? Right, this convergent. small one, the big one convergent, so small one must be convergent also, right? So this one is convergent. This is an example. So next question. Let's be term negative 1, 2, n. Let's convert or divergent. I can see that this geometry sequence, right? Look, when SQ1 just means negative 32, right? Plus negative 32, 2, 2/3, 2/3 power. Geometry sequence, common ratio, right? Geometry sequence, common ratio Q is negative 2 to 3. So by the formula, so sum of this is equal to 1 over Q numerator first term. So first term is negative 2/3. 1 minus common ratio Q. So simplify. So this one negative 2/3 plus, here's 1 plus 2/3, which is 5/3. So it is. Cancel out. Okay, that's a sequence. Okay, this question. Okay. Okay, we finished today.